more to this tutorial channel, Best Science Brain YouTube channel. Today we're going to take a look at organic chemistry. This aspect we're going to deal with homologous series. So if you are not subscribed to the channel, or you are seeing the channel for the very first time, go to the subscription button under the channel's name, Best Science Brain, the subscription bell or icon. Tap on it once and get subscribed so you see our videos on chemistry, physics, and further mathematics. Today we're looking at homologous series, so a family of organic compounds. But our focus today is going to be on the homologous series derived from alkanes. But first of all, we have to define what is meant by a homologous series, and then we'll look at the characteristics of homologous series, and then look at some examples, those of them that are obtained from alkanes. We say that in chemistry, homologous series is a family of organic compounds with the same GMF, meaning general molecular formula, in which each member differs from the next by CH2 methylene group or 14 atomic mass unit. So this is how we define homologous series. Family of organic compounds with the same general molecular formula in which each member differs from the next by CH2 group or 14 atomic mass unit. So what are the characteristics of a homologous series? What are the general characteristics? You have one, members of a given homologous series, that is homologs, have the same general molecular formula. For instance, you know that all alkanes correspond to the formula CN N2N plus 2, where N starts from 1. To get the first member, replace N with 1. Second member, replace N with 2. Third member, replace N with 3, and so on. Number 2, each member differ from the next by CH2 or 14 atomic mass unit. For instance, in alkane family, methane is CH4, that's the first member. Next is C2H6 called ethane. Next is C3H8 called propane. If you look at this, the difference between this and that is 1 carbon atom. 6 and 4 is 2 hydrogen atoms. Difference between 3 and 2 is 1 carbon. 8 and 6 is 2 hydrogen, and so on. Then the third property is members are prepared by similar methods. So members are prepared by similar general methods. Number 4, they have, or members or homologs have the same functional group. They have the same functional group and hence similar chemical properties. Like when all alkanes undergo substitution reactions, all alkenes undergo addition reactions. Then number 5, members differ in their physical properties. Members differ in their physical properties. Members of a given homologous differ in their physical properties. For instance, the first 4 members of hydrocarbons are normally gases. The 5th to the 16th member are usually liquids, while from the 17th member and above are usually, okay, this is 17, while above the 17th member are usually wax-like solids. So you see that they differ in their physical properties, and also you should know that their boiling point and melting point increase than the group. That is, the boiling point increase as the carbon atoms increase, like the melting point increase as the carbon. Like in that can have methane, ethane, propane, butane. As you go down, the boiling point or melting point will increase and the carbon atoms increases also. So these are the general properties of each homologous, of the homologous series. Organic compounds are so many. You can have millions of organic compounds, but those of them that are similar are brought together in one family. Those that have something in common, and what they have in common, when they have the same functional group in common, we bring them together and group them as a family, and this family is called the homologous series. That will have alkanes. Alkanes are homologous series. Alkenes, a different homologous series. Alkynes, a different homologous series. Alkanols, a different homologous series. So we're going to look at the different homologous series and see how we can name them, because in organic chemistry, the best way to understand organic chemistry is to know the homologous series and know how to define a compound and the family it belongs to, and how to name that compound subsequently by knowing its homologous series and knowing its functional group. Series, the first column, GMF, meaning general molecular formula, the second column, functional group, and then example. As I said in the early part of this video, so we are focused here going to be on the homologous series derived from alkanes or the aliphatic homologous series. So the first one we're going to look at is alkane and the homologous series. The GMF of alkanes is Cn, which I've done in our previous video, plus 2. N starts from 1. Or we can write it as R, symbolically as R linked to H. Know that R stands for the alkyl group, which is Cn, H2N plus. What is R group? Alkyl group. Then adding one more hydrogen. 1 plus 1 gives you 2. So you see that this is equivalent to that. Now the functional group of alkanes. All alkanes have single bond. So we present carbon-carbon single bond for all alkanes. So that's the functional group of alkanes. An example of an alkane could be an alkane that has only 1 carbon. If you draw the structure, which is this. So this alkane is called methane. So we have done the video on alkanes. You can watch the video from our YouTube. Then the second family we want to look at is the one called haloalkanes. Haloalkanes were formerly called alkyl halides. Haloalkanes, they are in fact nomenclature. The common name alkyl halides. So let's look at the alkane formula once more. Remove the one hydrogen from our alkane and put a halogen. Put this hydrogen and put that S stand for halogen. That S can be fluorine, chlorine, bromine, iodine. When I have a haloalkane. So the functional group remove the alkyl group, and that will leave you with the halo group. That's the functional group of the haloalkane, where S could be any halogen linked with a single bond. An example is, let's go to methane again. This is an alkane, and remove one hydrogen here and put one halogen like chlorine, which is certain as saying CH3Cl. This is called chloromethane. According to IUPAC nomenclature, we can call it methyl chloride by common name. Another example is this. This is ethane. C2H6 is ethane, alkane. Remove it and put one halogen, maybe bromine or chlorine. This is now called bromoethane. That is C2H5Br, as you can see there. So that's the haloalkane. The number 3 example of a homologous series obtained from alkane is the one we call alkanol or alkanols. The old name is alcohol. So going to this formula, R, the alkyl group of alkane, remove the hydrogen and bring in OH, known as the hydroxy group. Hydroxy group, we have the alkanol, which can be written as, also remember that R is CnH2n plus 1, and then bring in OH. So this and that are equivalent, where N also starts from 1, because this N is the alkyl group. So to get the functional group, detach the alkyl group as you did in this one. Remove the alkyl group, and that remains OH, that's the reactive group or functional group of the compound. Example of an alkanol is this one. This is an alkane, C2H6. This is an alkane called ethane. Move one of the hydrogen and bring in OH. You can see that. They are all derived from alkane. This is now like, this is C2H5, ethyl, and then OH. So this is called ethanol. The old name or common name is called ethyl alcohol. So S with OL because it's an alkanol. As you can see the name OL, alkanol. Then go to number 4. Number 4 example of homologous is what the one called monoalkanoic acids, or you can call them monocarboxylic acids. These ones have, to get them, the organic acids, you still go match up to the alkane. Remove one hydrogen. Remove one hydrogen for the alkane formula and bring the group COOH called the carboxy group. You see that the general molecular formula. To get the functional group, as we did in the other ones, remove the alkyl group. You now have COOH. So you want to draw the structure of this group. One carbon links with oxygen with a double bond. Then the other oxygen goes with a single bond. There is also a single bond between oxygen and hydrogen. That is it, called the carboxy group. An example is this compound CH3COOH. This is an acid, a monoalkanoic acid. To name this acid, when we want to name monoalkanoic acid, what we do is this. We count the carbon atoms present in the molecule, including the one in the functional group. This is 1, 2 carbon atoms. Then to name this acid, you ask yourself which alkane has 2 carbon atoms. The alkane that has 2 carbon atoms is called ethane. So this acid is called ethanoic acid. From ethane, ethanoic acid. And the example is this one, CH3, CH2, COOH. You can't have any carbon atoms. 1, 2, 3. Which alkane has 3 carbon atoms is propane. So this is called propanoic acid. So you go through our work. So we'll continue. So you see, for illustration, focus on the general molecular formula. The alkanes have single bond. The other groups are all derived from alkenes by removing the hydrogen there and putting other substituents. Like if you look at this one, this is haloalkane. Put the hydrogen and bring in L. This L represents the halogen. I have a haloalkane. To get the functional group, just remove the alkyl group. The remaining group becomes the functional group. Going to this one, to get this is alkanol. To get the alkanol general formula, move the hydrogen from the alkane and bring in one hydrogen from alkane and bring in OH called the hydroxy group. To get the functional group, detach the arrow group, remove the R, we now have OH, the single bond called the hydroxy group. Then go again to the alkane, remove the one hydrogen, to come down, have what they want called the monoalkanoic acid. Mono because it has one carboxy group. So we have this ROCOH. To get the functional group, remove the R, we now have COOH, that's the functional group, the carboxy group. Then we can look at the examples we listed. Alkanoids, also known as esters. The general formula is given as R, COOR. Let me put prime here to make the difference between this and that. Alkanoids. The functional group of alkanoids is, remove the first alkyl group, have COOR prime. Under the structure, we have C. One also linked to the carbon with a double bond. The other also linked with a single bond. And also the single bond between the oxygen and the remaining alkyl group, alkanoid. Example of an alkanoid is this compound, CH3, COOCH3. Look at it very well. How do I know it's an alkanoid? Look at the general formula. You compare the two. An alkyl group at the extreme, CH3, and the alkyl group at the extreme, and then COO at the middle of this. So you see that this formula corresponds to this. This alkanoid is called methyl ethanoid. Methyl ethanoid. We're going to throw some light on alkanoids for better understanding. Before we go on to the next homologous, we'll ask ourselves, how are alkanoids formed? Alkanoids are formed by reacting an organic acid with an alkanol. Reacting organic acid or carboxylic acid with an alkanol, you get alkanoid. How does the reaction go? The carboxylate ion, let's cut it from here, we combine with this alkyl group. Carboxylate ion, RCOO, combined with the alkyl group, that cannot giving us RCOOR prime. You see the general formula. While the remaining hydrogen ion will combine with hydroxide to give us water. So the reaction between organic acid and an alkanol is called esterification reaction. Esterification reaction. So this compound form is called an alkanoid or an ester. You normally have fruity or pleasant smell. So you see the reaction had that. So the alkanoid or ester has two alkyl groups. The first in the structure is from the acid. The last is from the alkanol from which it was obtained. So you can see how the formula was obtained. There are two alkyl groups. Some can write the formula as CN H2N plus 1 COO CN H2N plus 1. The same. This and this are the same. We cannot say that N will start from 1 or will start from any number because these two groups may be the same or may be different. Like in this case, this example, the two groups are the same. I can still have this one whereby the two groups are different from each other. So we cannot emphasize that M or D a particular value, but the two groups are from two different compounds. So this one is called ethyl ethanoate. Then, how do we name alkanoids? Although in this video we are not focusing mainly on nomenclature, but you can still look at how to name alkanoids. Here is the formula of alkanoid. To name an alkanoid, what you do, first, take the name of our prime, the last alkyl group. Take its name first. Then, name the ion, the remaining ion, ROC, that is the remaining group, and end it with a suffix, oet. For example, let's look at that first example we took. That is this first example. You compare it to the general formula RCOO prime. Here, arrow prime corresponds to CH3. So as the rule goes, first name the last alkyl group. The last alkyl group here is CH3. The name is called methyl. The remaining group, which is ROCOO ion, will now be CH3 COO negative. So if you count the carbon, there are 2 carbon. This is from ethanoic acid. If I should add hydrogen here, because a complete acid is ethanoic acid, if I should put hydrogen there. But remove the hydrogen, this is an ion. This is now called ethanoate ion. Ethanoate. So you join the two names, methyl ethanoate, as it goes there. Methyl ethanoate. If you look at the second example we took there, one example is CH3 COO C2H5. Remember that the sentence is writing CH3 COO CH2 CH3, because this and that are the same. 1 and 1 gives you 2, 2 plus 3 gives you 5. To name it, I take the last alkyl group, as I said. The general formula is RCOO prime. The last alkyl group is C2H5. Take the name first. The name is called ethyl, from ethane to carbon. Remaining this, the ROCOO ion is CH3 COO negative. So this is now called ethanoate. Ethanoate. So if you join the name, you have ethyl ethanoate. So as a little work, you can try this one. You can name this one yourself and see what you can get from it. C4H9 or C5H11. So we'll find out as we continue with our work. So we'll go to number 6. I'll come back to that later. Number 6. The next homologous series, apart from after alkanoids, we're going to look at is alkanals. Alkanals. Otherwise, it was formerly called aldehydes. Aliphatic alkanals. The general formula is RCHO. Alkyl group linked to this group, or CnH2n plus 1 CHO, where N starts from 0. So the alkanals. So the functional group is obtained by removing the first alkyl group. Here will have CHO, or when you drawn, the carbon goes also with a double bond, then single bond hydrogen. That's the alkanal group. Example is this one with 1 carbon is called methanal, from methane. Methane has 1 carbon. Or this one, how many carbon atoms we have here? 1, 2 is called ethanol. That is it. Have you got the name of this compound? This is C5H11 called pentyl. Pentyl. How many carbon atoms are here? 3 plus 1, 4 from butanoate. Pentyl butanoate. That's the name of the ester. Then number 6 family is alkanones. Alkanones were formerly called ketones. The aliphatic alkanones have the general formula RCOR. Remember that they are not esters, so look at alkanones. Have 1 oxygen in the middle, C, 1 carbon and 1 oxygen. Then look at esters. 1 carbon and 2 oxygen, they are different compounds. Alkanones, or you can write the formula as CnH2n plus 1 CO, CnH2n also plus 1. Alkanones. The functional group is the carbonyl group, just carbon, 2 oxygen atoms. So, the carbonyl group, the functional group of this, the carbonyl group. So, having done that, an example of alkanone is CH3, CH, where the formula is RCO, R. That is it. To name it, you name it the way you name alkanes. 1, 2, 3 carbon. 1, 2, 3. The alkane that has 3 is called propane. This is called propanone. Propanone. That is it. You can say butanone and so on. Having done that, the next homologous series, aliphatic homologous series, is the one we call nitrides. Nitrides. They had the general formula RC, triple bond, and then N. Are the nitrides, triple bond between carbon and nitrogen. The functional group, remove one, the alkyl group, we now have the functional group, the nitrides, or the cyano group, nitride group, or cyano group. Example, I can put any alkyl group here. I can use CH3, I can use C2H5, I have a nitride. So I have CH3, Cn. So this compound can be called cyanomethane. Cyanomethane. Another example in this one, CH3, CH2Cn, or written as C2H5Cn. There are 2 carbon atoms here, as you can see there. This is called cyanoethane, based on the IUPAC nomenclature. So we're not looking at the common names so much today, but when we go to nomenclature in details, we're going to combine both the IUPAC nomenclature and the common names of the different homologous series. Number 9 family is called the amines. But for now, we're looking at the primary amines. Although we have primary 1 degree amine, we have secondary or 2 degree amine, we have tertiary amine. Primary amine, the general formula is RNH2, the amino group. The functional group, inside the alkyl group, you now have NH2. Or structure-wise, you have it like this. That's the amino group. Let me draw it very well. Amino group. So, an example of the amino group, an amino compound is putting an alkyl group here, has CH3 NH2, called methanamine. That's IUPAC nomenclature. Then you have the ethyl group. Ethyl group is this. That is C2H5. This is called ethanamine. Amine. So these are the ways of naming primary amines. Although we're going to look at secondary amines. Secondary amine is where you have this structure. We want hydrogen. I'm bringing another alkyl group. 2 alkyl groups. Then this is the secondary amine. Then you can still have tertiary amine. When you have the 3 alkyl group replacing the 2 hydrogen. But we're going to look at that later on in a different video. Then number 10 family, we have the amines. But we'll look at the primary amines. Amines, different from amine. Amines, different compounds. They are not the same. The amines have RCONH2. primary amines. You can still have secondary amines. You can still have tertiary amines. In subsequent videos, we're going to look at the overall nomenclature of these compounds. So, the functional group, the first alkyl group, remove it. We now have CONH2. This is the functional group of amines or primary amines. An example of a primary amine is using an alkyl group here. I have CH3CONH2. These are examples of a primary amine. So, how do we name amines? To name amines, the hyper nomenclature specifies that you have to count the carbon atoms. There are 2 carbon atoms. The same way we name amines. 2 carbon, ethane, ethanamide. Then 2 carbon here, this is called ethanamide. Look at the difference. Amide and then amine. Then another example, let's say you have CH3, CH2, CO. This one is an amide. Look at this one. Look at the functional group. Identify the compound. 1, 2, 3 carbon. This is now called propanamide. You see that? So you see that the best way to identify organic compound is look at the structure, know the general formula, and know the functional group. For instance, somebody gives you this structure. You have this, have this, have this, have that. You ask them the compound. The only way I can name this compound is to know the family where it belongs to, and they are able to name it properly. To know where it belongs to, I'll have to squeeze everything together. This is 1, 2, 3 carbon, C3, hydrogen 5, 7, H7, COO, bring them together, COO. Then C2H5, C2H5. You look at it, this is as that. The which organic compound has CO at the middle? That is most likely to be an ester. Look at the form, you see, it's an ester. This is an alkyl group, propyl group, alkyl group, ethyl group, then COO at the middle. So I'll now use the nomenclature of esters to name this compound. To name esters, we'll take the last group. This is called ethyl. C2H5 is taken first. The remaining group is now 3 + 1, 4 from butane, butanoate, ethyl butanoate. You see, the best way to name organic compound is to first of all know the general formula and then equate the structure of the general formula and then be able to name it subsequently. And the example is maybe you have CH3, CH2, CH2, CO, then CH2, CH3. Name this compound. How would I name this compound? I have to first of all find out which family does it belong to. This is 1, 2, 3. 1, 2, compress it. C3, H7, CO, compress there, C2H5. Is this an ester? No. An ester would probably have COO towards the middle. So where does it belong to? Let's look at the formula COR. An alkyl group. An alkyl group. So this is not an ester. This is an alkanone or ketone. Alkanone or ketone. So if I want to name this compound, as a beginner, I have to open the structure. This 3 hydrogen, 3 carbon, and 7 hydrogen. Like this one. Then oxygen double bond here. Then that is it. So to name alkanones, they end with "-one". If I count the carbon 1, 2, 3, 4, 5, 6, this should be hexanone. Hexanone because of 6 carbon atoms. But IUPAC does not specify that we should name it this way. But it should have the root name of hexanone. You have to know the functional group is this, the carbonyl group. The number, the chain from the end that gives the smallest number. You have 2 ends, A and B end. The end that gives the smallest number to the functional group. Here I'll give you 1, 2, 3, 4. Come on, the functional group. This I give you 1, 2, 3. So these are preferable. One that gives you a smaller number, a close proximity to the functional group. So this is called trihexanone or hexantrione. So that's the proper way of naming it. So we shall come across all these in our subsequent videos, how to name organic compounds in detail, give you the rules, and then name them. We're going to use the alphabet nomenclature, and also use the common name, depending on where you're watching the video, from whatever country you're watching the video. Some countries are using the alphabet nomenclature, while some countries are using the common names. So you can key into our video and understand it. While some countries, they use both the nomenclature and also alphabet nomenclature and also use the common names. So the next video, we're going to look at nomenclature in detail of aliphatic compound. But for now, study this table so you can be able to identify a compound and know the family where it belongs to. So thank you for listening.